Okay, e-learners, in the Blue Book on page 589, I'd like you to do problem 9.25. Not you, Vivian, Cameron, but okay? Okay, so now we're on part A. Okay, so the first question is find the mean and the standard deviation of p hat of the sample who jog. Assume the sample is an SRS. That's really important, and we'll talk more about that. So what is the mu? What is the mean? I shouldn't say the mu, but what is the mean? So when you go to write it, mu of p hat equals p, which equals 0.15. So that's your mean. How do you write your standard deviation?
Sigma
Of p hat equals what? Over what's the sample size?
1,540.
And that equals what? Okay, so again, this is p, this is 1 minus p, and then over the sample size. And you guys, your n never changes, okay? So whatever your sample size is what you use. And you guys, you always want a fairly decent sample size. Again, though, you don't want your sample size to be so much larger that it doesn't meet that 10% rule. Okay. So B, are there any questions over how we found the mean or the standard deviation? Are we good? Okay, so B, it asks you how we can use the standard deviation, if we can use it. Can we use it? So the population of what? Who is the population? Was it specific? Just adults. So population, did it say US adults or just adults?
Adults.
Okay, so population of adults. It needs to be greater than or equal to what? 10 times 1,540, which is 15,400. Is the population of adults greater than or equal to that? Yes. So we need to write a sentence. Okay. C is it approximately normal? So how do we prove approximately normal? So what is n? And in this case, our sample size is 1,540 times 0.15, and that has to be greater than or equal to 10. This is 1,540 minus, 1 minus 0.15 is 0.85, and is that greater or equal to 10? Okay, so how do you think we're going to write this? You guys, you can't just leave it like that. what does that, all that shows is that you know, okay, that's the rule, but what does that mean?
It means it's large enough to assume that's a normal distribution.
Yep. Now this rule will not change when we get to chapter 10, 11, and 12 when we're dealing with proportions. This is how you will always prove normality when we do significance tests. Because the reason I keep bringing up the no pomegranates is you're going to find out today. Because this rule only works with proportions. Okay? So, you guys, if this was a free response problem, do you see how I'm everything, like in B, I took it back to the population of adults, and when we do p-hat, we're gonna start making everything related to that problem. Okay, and you guys can't see that. I was gonna change this. We can use the normal approximation. You could also say, since n times p is true, we can assume that it's approximately normal. Okay, so there's a whole bunch of different ways, but you need to relate it back to that sentence. Okay, so now D is it's asking you to find, right? It's asking you to find the probability between 13% and 17%. Now we're going to go back to chapter 2 when we used our z-score. So what do you need to draw here? A what? You need to draw a normal curve. So there should be a normal curve. So we're going to draw now. Should the normal curve be tall and thin, like tall, or should it be wide? Tall and thin. Why should it be tall and thin?
The standard deviation is small.
Yes, because the standard deviation is small. If the standard deviation was like 25, we could get away. I think when we were in chapter 2, someone said, what happens if you don't draw? That's fine. They want to be able to read it. But I just want you to remember that if you can get it as close to what it needs to be, I mean, I'm going to tell you that that's probably still too wide for our standard deviation, but we'll use it so that we can put everything in. So you guys, our P is going to go here, and our P is 0.15. And then we're going to go out 3 standard deviations on either side. And I have these all written already because I did this problem. Aren't you impressed? You're like, no. So 0.1773, 0.1682, 0.1591. This one is 0.1409, 0.1318, and 0.1227. Okay. And we want it between 13% and 17%, right? So there and here. We want it shaded. So you guys, it's really close to being almost out 3 standard deviations, right? So it's going to take up a chunk of area. So how do you find the z-score? Let's talk about that.
Observation minus mean over standard.
And what is our observation? What's our first observation, you guys? What's our P?
0.15.
What's our standard deviation?
0.0091.
Find the z-score. What's our next one?
0.17.
Minus divided by let me say it again. So everything right now is going back to chapters 2 and 7, where we use the normal curve, we found the z-score, and we look it up. The difference is how the standard deviation is affected. And that means because of our sample size, standard deviation is going to be affected. So whether it is a proportion or a mean, standard deviation is going to be affected. You have to be able to prove, why can we use the standard deviation? Why can we use normality? And then can you go back and find the z-score and shade it? So that's what this whole chapter is about, okay? Finding that probability. Because then when we go to chapter 10 in the blue book or chapter 8 in the flamingo book, we're going to start using this information to determine significance test. So what was the z-score for 0.13 minus 0.15? What was the z-score for 0.17 minus 0.15 divided by the standard deviation? 2.2. Okay, so what is the area of of this one, of the positive one? So let's talk about that. What is the area of the 2.20? What was that area? So the area of the positive z-score is 0.9, what did you say?
0.9861.
Okay, and then what is the area of the negative z-score? So we're going to subtract them. So we found the z-score, I found the area for both of these. But I want to subtract it because it's between. So what is the total area that's shaded in? Okay, the question asks, find the probability that between 13% and 17% of the sample jog. So, what? Yes, it is. Okay, so what is the answer? I want to see how I wrote it, because the probability that between 0.3 and 0.7 of the sample jog, I'll show you what I wrote. When you do these problems, you can't just leave it like this. You need to write it back in context of the problem. Always. After everything, because especially next unit, we're going to start talking about, and we're going to have to put it in context of the problem. What is that noise? What are they doing? Okay, so we did, I think I gave you a couple problems. Didn't I give you like 9.19 and 9.20 in the blue book last week? Because I asked you to take pictures. Okay, remind me tomorrow and I'll post those answers so you can check them, because but now does it make sense? This is a free response question. So you can expect this. What's the mean? What's the proportion? Does it meet standard deviation? Does it meet normality? And then they're going to give you a probability. Whether it's in between two numbers or whether it's lower or higher. And we're going back to that chapter 2 and chapter 7 probability. We're dealing with those continuous variables again. I don't want to say random, but we're dealing with that. So are there any questions over 9.2? I want to start on the notes for 9.3, so let's take those out. You guys, if you have questions, you're not sure about something, you want to go over something, I am available for you guys before or after school. I know e-learners, I'm available for you. You just have to message me. Okay. Is it this one? We're just going to go through this. You guys, this is basically just a quick review of what we just did. So, if we have, what do you think if we have categorical, can you guys see that?
Yeah.
Okay. If we have categorical data, then we must use sample proportions. You guys, you're going to use sample proportions in a lot of yes or no questions. The question was, do you jog? That answer is yes or no. Do you drink the cereal milk? Yes or no. Do you like to drive? Yes or no. So those type of questions, those are categorical questions. That's when we're going to use the sample mean, or their sample proportion. And then, do you have brown eyes? Do you have blue eyes? When we start talking more than one, we're going to talk about that. So suppose we want to know how many seniors in Florida plan to attend college. We want to know how many seniors would answer yes to that question. Do you plan to attend college? These responses are categorical. So P, which is our parameter, is the proportion of all seniors in Florida who plan to attend college. Those are the kids that answered yes to our question. You guys, please understand also, you could change this and say you want to know how many kids don't plan to go to college. So no could be what you're looking for as well, okay? Let P hat, our statistic, that's the proportion of Florida students in the SRS of size 100. So we're going to pick the size of our sample, okay? To calculate the value of P hat, we divide the number of yes responses in our sample by the total number of students in the sample. So if we had 54 people that answered yes and we had 100 in our sample, that's how we find our P hat. If I graph P hat for all possible samples of size 100, then I have constructed a sampling model. So the sampling model is graphing all the sets of our 100. It will be approximately normal. In fact, the larger my sample size, the closer it will be to a normal model. Okay, so we want our sample size to be larger. And you guys also remember that if you want to decrease bias, you want your sample size to be larger. Both n times p and n times 1 minus p or q should be at least 10 in order for normal approximation to be useful. And then just one more thing. What time do we get out of here? 1 minute. We're almost done. P times 1. Ah! There we go. That's the end of it. Right there. Please start reading section 9.3. Start working on those objectives. Make sure you have 9.19 and 9.20 done. Okay? Thank you. Have a great day.